Hello, Luke. Welcome to lesson 28. So today we're going to be talking about fractional parts of a number and some functional notation. So we're kind of starting to get into a couple of newer things here. Let's start with fractional parts of numbers. And what we're talking about there is actually just word problems. All right, we haven't done a lot of those yet. So today we're just going to touch on them a little bit, and we're going to look at a couple of different clue words, I guess, that we'll be using when we solve these word problems. So one clue word, well, actually, you know what? Let's just begin with a word problem, and then we'll kind of break it down. So if they were to give us something that looked like this, what is 7/8 of, let's see, let's go 64. All right. So if I were to say, the word problem is what number is 7/8 of 64? Okay. So that's the question. What number is 7/8 of 64? And we'll be doing a lot of these short little word problems. And the thing to look for are some clue words that help us kind of set this up in an equation, because that's what we're going to be trying to do. We're going to be using equations to solve this kind of a problem. All right. That's really what we've been working towards with the equations lately. So when we're looking at a problem like this, the one thing that I'll throw at you right away is in word problems, whenever you see the word is, almost always that stands for equals. All right. Almost always you can just throw in an equal sign where you see the word is. All right. The other clue word here is going to be the word of. And again, almost always that of is going to represent multiplication. Okay. And if you can remember these two things, it makes life a lot easier with these problems. Okay, so looking at this, we have what number is 7/8 of 64? Well, if you kind of think of it in terms of these clue words, we see this is here. Well, that represents an equal sign. And then we see an of here. Well, that represents multiplication. Okay, and you might ask, what are we looking for? We're looking for this guy, this what number. All right, now we don't know what this number is. That's the question mark. That's what we're looking for. What number? What number is or equals 7/8 of, or multiplication, 64? Okay, so if we kind of think about this in terms of mathematics, what do we do when we have a question mark? What do we do when we don't know the value of something, but we want to write it in an equation? Well, we use a variable, right? And we might use an x, we might use a y, we might use a z. In this case, we're going to try to make it a little bit more intuitive here, make it mean something. And so we're going to actually use a combination of letters. We're going to use what number, we're going to use a wn. Now, don't get confused here. This wn in this particular case is not meant to signify or to represent w times n, like variables have in the past. We're kind of considering this as one variable. All right, it's one solid variable. There is no multiplication being done between these two. It's just two letters being used to represent one variable. And we wouldn't have had to have done that. We could have written that if we had wanted to. We could have written that as just a w, maybe, or we might have just written it as a number. Right? But in this case, just to make it clear what it represents, we'll use the letters WN. We'll capitalize both of them just to represent that they're together. Okay. All right. So let's make sure that's clear. All right. That's just one variable. Okay. So we have what number. That's what we're using as the question mark. And you know what? Maybe we'll just, to make it more clear, we'll use the same color as we used with the question mark. So we'll make that a what number, wn. All right. Then we have this is, which is the equal sign. And then we have 7/8. Well, that's a number. We can definitely write a number in an equation. So we write that as 7/8. Then we have this of, and that we said was multiply. So we put multiplication right here. And then we have a number again, 64. So again, that's just a number. We can put that in an equation. And now we've got an equation that is comprised of numbers, the 64 and the 7/8, and one unknown, this wn, right? Now we can solve this because it's one unknown and we have numbers. It's an equation. So we can work this out just like we've worked so many equations up to this point. So let's go ahead and simplify this. There's nothing to simplify on the left side. On the right side, we can certainly multiply this out. Let's just put this over a 1, so it's a fraction. And then we can simplify. So 8 can go into itself once. 8 can go into 64 8 times. And then 7 times 8, well, that's 56, right? So the what number is equal to 56. So if I were to read that back, I could say that 56 is 7/8 of 64. Okay? Does that make sense? Now, you might be wondering, how in the world does of represent multiplication? Maybe you didn't recognize that right away. 7/8 of 64. Why does that represent multiplication? Well, what if I were to say something in a little bit to say this, like, for example, if I would go, what's 1/2 of 4? Now that you should be able to do in your head. What's 1/2 of 4? Well, we know 1/2 of 4 is 2, right? Or if I were to say, what's 1/2 of, 20? We might say, oh, we know that's 10. That's what 1/2 of 20 is, right? But now let's just test this, and we're not actually proving it, but we're going to test it and see if this of as multiplication really does make sense. So what is 1/2 times 4 if I replace this of with a multiplication? And if we do that, whoops, excuse me, we'll put that over 1. If we do that and we cross cancel, what do we get? Well, 2 in the numerator, 1 in the denominator, we get a 2, which is exactly what we said earlier that it would equal. So 1/2 of 4 does indeed equal the same thing as 1/2 times 4. All right, let's try this one. If it's 1/2 of 20, well, what's 1/2 times 20? Put it over a 1. We can cross cancel here. And lo and behold, we do end up with a 10, right? So you can see that of indeed does indicate multiplication. All right. So again, this is what you need to remember when we're talking about these fractional parts of numbers, these word problems. You need to remember that is represents an equal sign. Of represents multiplication. And if you can remember that, things get easier. Okay. Let's try another one though. What if I go let's switch it up here a little bit. Let's go 3/4 of what number is 69? 3/4 of what number is 69? Okay. Now it's a word problem, but we're going to try to write this as a mathematical sentence so that we'll have an equation that we could then solve. All right. So if we just read it from left to right, we see that we have 3/4. But then again, we've got this of right here. And what did we say of represented? Of represents multiplication, right? So it's going to be 3/4 times. And then it's 3/4 of what number? Well, this is the number we're looking for. This is the question mark, the unknown. We don't know what number is. So that is where we use our variable. And remember what I said earlier, we'll use, excuse me, the variable wn to represent what number. Okay? And then we've got is. So 3/4 of what number is? Well, is equal, right? So we can write that. Equals, and then we have just a number, which we can definitely put that in the equation, 69. And lo and behold, we end up with an equation. So here we have it in written form, word form, 3/4 of what number is 69. This you could also read as 3/4 of what number equals 69. I could read it the same way. I'm just kind of translating it. The multiplication means of, the equal is. So 3/4 of what number is 69? Okay. So you're just translating this word problem into a mathematical problem. Okay. Understanding the language of math and the symbols of math. All right. So at this point, we just have an equation, and now we just need to solve. And we can do that the same way we've been doing all of these equations. In this case, we have the what number. That's what we're trying to get by itself. So we need to get rid of this 3/4. And to do that, we could multiply it by its reciprocal. Remember, if we multiply this by its reciprocal, well, we have to do that over here then as well. These will then, cross out, and we just are left with what number on this side. And then over here we have 69 times 4/3. Well, we could divide this, set that over a 1. And then we could do a little cross canceling here. If you look at it closely enough, you could recognize that 3 can go into itself once. 3 can go into a 69 23 times. All right. And then we can multiply the 23 times the 4. And if you want to do that off to the side, that's totally fine. Multiply that out. We get a 92. So the what number is going to be 92 in this case. So 3/4 of 92 is 69. All right. Okay. Very good. Let's try another one. What if it says, let's see. Well, we'll go back to the black here. If it were to say, what fraction, we'll go with a what fraction this time, of 40 is 24. So what fraction of 40 is 24? So just kind of think about that for a second and think about what they're asking. What fraction of 40 is 24? So throw out a fraction, half. If I just chose, let's throw 1/2. Well, 1/2 of 40, we know that 1/2 of 40 would be 20. They're looking for something that would give us 24. So obviously 1/2 is not the answer, but sometimes throwing a guess out there kind of helps us understand the problem. So 1/2 of 40 is 24. No, that's not true. 1/2 of 40 would be 20. But you can see what we're trying to do. We're trying to determine a fraction here. That if we take that fraction, times it by 40, or multiply it by 40, we're going to get 24 as an answer. All right. So let's write this out in mathematical form. And again, the thing that we're looking for is the what fraction this time. That is the question. It's what we're trying to discover. So that will be our unknown, our variable. Now, before I use Wn to represent what number, this time we'll just use a Wf to stand for what fraction. All right, just to remind us what it is that we're looking for. All right, and then we've got multiplication, right? We've got of, that means multiply. And if I just kind of run over to the is here, that's going to be equals, right? So now let's write this out. We have what fraction of, we'll just get a different color here. So what fraction of 40, well, we know we can write that. 40 is, that's our equals, and is what? Is 24, so that we have our 24, right? Now again, we've got our equation. Now all we have to do is solve for the WF. So in this case, we're going to divide both sides by 40, get that WF by itself, and we end up with what fraction equals 24 40ths. Now, 24 40ths, that can be reduced, right? Well, what can go into there? I think, let's see, 4 can go into there. So 4 can go into a 24 6 times, right? 4 can go into a 20 10 times. We could even go one more here. So 2 can go into 6 3 times 3/5, right? So if we reduce it down, we end up with the fraction 3/5. So the what fraction is 3/5. 3/5 of 40 is 24. All right? So hopefully that makes sense. It's not difficult. What you do need to remember is these clue words. The of means multiply, is means equals, and what fraction or what number or the thing that you're looking for, that's the variable. All right, and then you just need to write your mathematical sentence instead of your word sentence, and then solve the equation that you get. All right, excellent. So let's move on to our next concept here. Now we're going to start talking about, and maybe we'll just write this out, we're going to start talking about functions. So this is going to be good. So when we talk about functions, let's actually first start with an expression. And let's keep it simple. Let's do a really easy expression. Let's make the expression x plus 3. All right, I think we can both agree this is an expression, a mathematical expression, and all mathematical expressions have values. So remember, 2 plus 2 is a mathematical expression. 3 plus 7, 6 minus 2, 3 times 4. These are all mathematical expressions, and they all have values, right? They represent values. So 2 plus 2, the value of that is 4. The value of 3 plus 7 is 10. The value of 6 minus 2 is 4. The value of 3 times 4 is 12, right? So these are our values. These are our expressions, right? And every expression has a value. Now here we have an expression, but if I were to ask you for the value of this expression, you would probably tell me, I don't know what it is. I can't tell you what it is, right? Because I don't know what this x is. This x could be hiding who knows what number behind there. It may be a 2, it may be a 2 million, it may be a 0.789. You just don't know what this x is hiding. So we can't really determine what the value is for this particular expression, all right? So what does this equal then? Well, if we don't know what this equals, we might just say it's going to equal, I'm going to say it equals y. And what is y? Y is equal to the value of x plus 3. All right? So it's kind of a redundant way of writing it maybe, and it may seem kind of silly, but we're going to see how this kind of actually makes sense. So x plus 3, what's the answer to x plus 3? We don't know, so we're going to give it a variable, another variable. We're going to give it the variable y. We're not going to give it the variable x because x plus 3 may not equal x. If we give a value, if we know what x represents, then x plus 3 may not equal x. So we have to give it a different variable. We're going to give it the variable y. So this y is just some number that you get when you add x plus 3. All right. So what can you say about this value, y? Well, it depends. The value of y will depend upon what x is. So if x is a 1, well, then the value of y would be 4, right? If x were a 2, well, then the value of y would be 3. Or excuse me, would be 5, right? And maybe I should just write that out. Let's just do some scenarios here. If x is a 1, let's just say x is equal to a 1. If x is equal to 1, well then y is going to equal this x plus 3, right? Which would now be a 1 plus 3. Then y is going to equal a 4, right? If x, on the other hand, is, let's say x is equal to a 2, well then y is going to equal, this time, 2 plus 3, which is equal to a 5, right? And I could keep going on forever. What if x is 3? What if x is 4? What if x is, x is pi? What if x is 3/4? I could keep going on with all sorts of different values for x and plug that in to find out what the value of y is, right? All right. So the point is that y depends. The value of y depends upon what the value of x is. So in order to know y, we first need to know what the x is. All right. So if I were to say, well, let's determine some possible solutions for y, possible values for y, we would do exactly what we just did. Well, let's say x is equal to 1. Then y would equal to 4. So one possible solution, or one possible value for y is 4. If x is equal to 2, then y is equal to 5. So then one possible value for y is 5. If x equals 3, well, let's just do one more. Y is going to be equal to 3 plus 3. Y is going to be equal to 6, right? So 6 would be another possible value for y if x were a 3. Okay? So you can kind of see how this is working. We have many, many, many different values for y. All right? Now just hold that thought. We're going to come back to it. But just let's talk a little bit about this equation that we have here. Because actually, it seems pretty simple the way we wrote it out, but this is extremely important. We give this whole equation that we have here a special name. We actually call this equation a function. All right? So this equation that we made right here, this guy, this wonderful equation, this is a function. That's what we call it. We call it a function. Okay, and a function is where you have a variable such as y set up so that it equals some expression that has another variable in it. All right. Most of the time when we write functions, we'll write this y first. So most of the time we'll write this as y equals x plus 3. All right. It's just kind of a standard procedure. That's just kind of the way we usually write it. It doesn't change anything when we reverse it like we did here, but this is just the more standard way to write it. Y equals x plus 3. We'd write the y first. Okay, very good. Now, the next step here is the next step in functional notation. So this represents a function. Okay, now sometimes I might want you to evaluate the function. Okay, and think about how we've done evaluation problems up to this point. You might recall you've done a lot of problems now that look something like, a, b, c plus 4b, and they want you to evaluate this if a is equal to 1, b is equal to -1, c is equal to a 2, right? And you would plug these in, and then you would get your value for this expression, and then that would be your answer, right? So these are problems that you've done many, many, many times at this point. That's actually all that we're going to be doing kind of here too. It's just a little bit of in a different notation. So here we have y is equal to x plus 3. This is the expression, right? And again, this y depends upon what x is. So if I give you a value for y, I might ask you to evaluate this expression the same way that you've done all of these if I tell you what x is. All right. So another way to write this y, and this will make sense in a second, but if I take this y, another way to write it is to write it as f of x. Now that might look really confusing to you, but it's not, so don't let it scare you. F of x, that's how you would read that, f of x, all right? And what this is this is just another way to write a y, okay? It's just another way to write a y, okay? The beauty of writing y as f of x is that we're seeing what variable we're using to plug in for x, or what value we're using to plug in for x. So I'm going to try to make this a little bit more clear. F represents a function. That's why we use f. Most of the time, you'll find that we use other letters too. But f, in this case, we're going to say it represents the word function. Okay, so whenever you see f of x, you know that we're saying it's a function of x. Okay. Now, if I say f of 2, for example, all right, this does not mean f times 2. Okay, so let's make that clear right away. When you see that variable f with parentheses next to it and a number inside that, it's not indicating f times 2 or f times parenthesis 2. Okay, that is not the case. So make sure you don't get that confused. This is just a way of writing y, which we already decided y here is the same thing as x plus 3. That's what y is. It's the value of x plus 3, right? So this f of 2 is just another way of writing the y when x is 2. So I'm going to say that again. This f of 2 is another way of writing y when x is equal to 2. So to write this, I would say f of 2 equals, now instead of an x, I'm going to write a 2. And then I still have this plus 3. Plus 3. Okay? That can be simplified. What is 2 plus 3? It's 5. Right? So f of 2 is equal to 5. F of 2 is equal to 5. All right? And again, all that means is that the y value, the value of this y, will be a 5 when x is 2, which is exactly what we did over here. Right? We said if x is 2, what's y? Well, we just plugged it in. Y is going to equal the x, which is a 2 now, because that's what we said x was, 2 plus 3, and we said, oh, well, then y is equal to 5. All right? So all this is saying is that the function when x is 2 is equal to 5, which means y is equal to 5 when x is 2. Okay? So let's try a couple of examples of this, and hopefully this will make it more clear as we do them. So if the function, let's just give you a function. I'm just going to kind of create a little space over here. Let's say we have a function, f of x. And let's say f of x, the function, is equal to 2 times x, or 2x. All right? If this is the function, now remember, this f of x, you can think of this f of x as just a fancy way of writing a y, right? And this is just the expression. So we have an expression, 2x, and I'm saying, what's the value of 2x? And you say, well, I don't know what it is. I don't know what x is. So I'm just going to say it's a y. That's what it is. It's a y. And y represents whatever 2x is. Okay? Now I can then write that y as an f, as a function, f of x. All right? And all that means is whatever x is, well, that's going to tell me what f of x is. That will allow me to discover what f of x is. So if I say then, what is f of 1? Well, f of 1 would indicate that we are plugging in for this x a 1. All right? So it'd be 2 times 1, which is 2. So f of 1 is equal to a 2. Okay? What's f of 2? Well, f of 2 is where we plug in this x here is now a 2, so we have to plug in the 2 for the x over here. So it's going to equal 2 times 2, right? Which is 4. So f of 2 is equal to 4. What's f of 4? Well, f of 4 is equal to the 2 times the x, which we said now is 4, which is equal to an 8. So f of 4 is equal to 8. Okay? You following this? So all we're doing is we just have a function, and we're just plugging in different values for x to find out what the value of this expression would be, given that value for x. All right? So hopefully that kind of is sinking in and making some sense with you. Let's maybe just try a couple here and see how you do. We'll just try to make the equations or the expressions maybe a little bit more complicated. So let's try this one. What if I've got the function of x. And let's say that function is equal to x, parenthesis x squared, minus 3x. We're just kind of making it a little bit more of a complicated expression on the right-hand side. All right. So let's say this is the function, which again, right now, there's nothing you can really do with it. We don't know what x is, so we can't really solve any of this. But let's say that I told you, okay, given this function, find for me f of 2. So what is f of 2? That's my question here. What's f of 2 if this is the function? All right. And the answer is we just need to plug in the 2 for all of our x's. So f of 2 is going to be equal to, now here we have, it's now basically an evaluation problem. We have an x, which we know is a 2. So like when we did evaluation, let's just throw that into a set of parentheses, 2. Again, later down the road, when you get really good at this, you can do it without the parentheses, but let's just practice it with. So we have a 2 for our x. Now we have to upgrade this parenthesis to a bracket. Remember that? And then we have an x, and we said x is 2, so we'll put that into a parenthesis, and then that parenthesis is being raised to a 2 minus a 3 times an x, which we said was a 2. And we have to upgrade this parenthesis to our ending bracket. Right? So that's kind of, we've plugged everything in. Okay? Now we still have this f of 2. We'll just rewrite it. F of 2 equals, we can start simplifying. So we have a 2 in parentheses. Well, we can eliminate the parentheses and just recognize that we're multiplying that by the bracket still. Inside the bracket, we have a 2 raised to the second power. That's going to be a 4. And then we have a minus 3 times 2. Well, that's a minus 6. Right? And now we can keep going. The 2 bracket, let's figure out these brackets. 4 minus 6, well, that's a negative 2. And now we've got a 2 times a negative 2, which is a negative 4, right? So f of 2 is going to equal a negative 4. That's what f of 2 is. So the function evaluated at 2 is equal to a negative 4. All right. So try to get familiar with these terms. Function, f of x. F of x is dependent upon what x is. All right. Those are all expressions that you're going to hear a lot of in the upcoming lessons. So try to get familiar with those. So when you do your problems, kind of say those in your head so that you get used to that language, f of 2. Okay. All right, so there's one thing I want to point out here. That up to this point, we've used the terminology or the notation f of x, right, for our function notation. Now, it doesn't have to be f of x. It could be many other things too. Some of the more common ones are g of x and h of x. Okay, these are the more common ones that you will see. So all of these are just different ways that we tend to use to write functions in math. All right, so I might say f of x, well, that's equal to x squared. Okay, and I might say, oh, g of x, well, that is equal to 1 over x. And I might say, oh, h of x, well, that is equal to, 2 times x. Okay, each one of these are separate functions, and they're just labeled differently. That way, if I say, okay, given these 3 functions, find for me, g of 1. All right, if these were all labeled the same, f of x, f of x, f of x, and I said find f of 1, you wouldn't know which one of these to plug the 1 in, right? So that's why we label them differently. But they all represent the same concept. They all represent a function. So a g of 1, well, I'd have to go to the g function and plug in 1 for x. And that's just going to give me 1 over 1, which is 1. So g of 1 is equal to 1, right? And if I were to say, okay, well, that's great. Now find for me h of 0. Okay, well, then you would have to go to the h function. We'd say, okay, h of 0 is equal to 2 times 0, which is 0. So h of 0 is going to be 0, right? And then finally, I might say, well, what's f of 3? Okay. And we go to our f function. F of 3 is equal to 3 squared, which is going to be equal to 9. So f of 3 is equal to 9. All right? So don't get confused when they throw at you a g of x or an h of x. They're just exactly the same thing. They're just using a different variable instead of the f. All right? Great. We'll try one last one here. So let's try, let's make the function be f of x is equal to x squared multiplied by 2x minus 1. Okay, and I want to know what is f of negative 2? Question mark. All right, why don't you pause the video here and see if you can tell me what f of negative 2 is, and then we'll do it together. All right, so hopefully you just whizzed right through that without a problem. Let's go ahead and try it. Maybe we'll do it in blue. So f of x, we want f of negative 2. So if we have f of negative 2 equals, now we plug in a negative 2 for this expression. Again, it's just an evaluation problem when x is equal to a negative 2. So we have an x, we put that in parentheses, negative 2 raised to the second power, bracket 2, negative 2 in parentheses, minus 1 bracket, right? And now we can go, what's our negative 2 raised to the second power? Because that power is outside the parentheses, we include the negative sign, right? So negative 2 times a negative 2, it's a positive 4. Then we have our bracket, and we have 2 times a negative 2. Well, that's a negative 4, and we still have that negative 1, right? And now we can solve the inside of these brackets. That'll give us a negative 5. And then 4 times a negative 5, well, that's a negative 20. So f of negative 2 is equal to a negative 20. Okay? F evaluated at negative 2 is a negative 20. All right, so hopefully that's what you got on your separate sheet. If not, look through this carefully. And if you have to, back up the video again and just make sure that you've got this down pat. And I think that's actually where we're going to stop today. So go ahead and work on that seat work, and we'll continue with some more of this in the upcoming lessons.